Hello, AP Calculus students. This is Mr. McAllen speaking, and the purpose of this video is to help you review a few concepts for how to deal with particle motion and different types of questions that they could ask you if given a velocity function on the AP test. For example, one of the first questions they could ask you is to find the velocity at a certain point if they give you the velocity function. This is pretty easy because we just have to plug in pi over 4 into our velocity equation. So the velocity at pi over 4 would equal 4 times the cosine of 2 times pi over 4, and that would be equal to 4 cosine of pi over 2, which equals 0. If you look at the graph, this is not a graph that they would give you on the test, but I plotted this on Desmos, and you can see at pi over 4 we have a 0 velocity. Let's just say that our units are in meters per second and time is in seconds, so that we can assign units to all these problems that we're going to work on. Next thing, they may want us to find acceleration at that moment. And if you look at the graph that we have drawn here, you can see that our acceleration would be the slope of the tangent line at pi over 4. And that would equal a negative quantity because the velocity is going down. What they expect us to do on the AP test without a calculator is take the derivative of this function. So since the function was 4 cosine of 2t, you would take the derivative of the velocity graph. That would make acceleration. And remember the chain rule. So you have 4 sine of 2t. Remember it's negative because the derivative of cosine is negative sine. And then you have to remember the chain rule, multiply it by the derivative of the inner function, which is 2t. Its derivative would be 2. Final result would be negative 8 sine of 2t. Acceleration at pi over 4 would be found by plugging in pi over 4. That would equal negative 8 times the sine. 2 times pi over 4 is pi over 2. Pi over 2, which would equal 1 value. So the answer for acceleration would equal negative 8. Units would be meters per second squared. The next question is find the object's, is the object's speed increasing or decreasing at t equals pi over 4? Why or why not? Well, the speed question is an interesting question, and we can answer it two ways. First way is if we have a velocity graph, and you make the velocity graph a speed graph, by simply taking any negative value, and you can see the velocity is negative here, and making it positive, you now have yourself a speed graph. So the graph in black would be a speed graph. So at pi over 4, the velocity or the speed is 0, and at that point, moving forward, you could see that the speed is increasing up until you get to pi over 2. So you could say into the AP readers, I created a speed graph by considering the absolute value of my velocity graph, which is totally acceptable as far as an explanation, and you just state, or in the sentence you would write how you view the speed graph from the velocity graph. So that would be one way to do it. The other way to do it is to look at how velocity and acceleration, what their signs are so it's a sign test at the time they ask you to check at pi over 4. So if velocity and acceleration are in the same direction or have the same sign, then you know the speed has got to increase. An example of this is if you're backing your car up and you have the car in reverse, your acceleration is negative because you're accelerating in the negative direction, and your velocity is negative as well. Because they're both negative, that means that your speed is going to go up. And if the same were true, if your acceleration, if you were in drive and you were accelerating forward and your velocity is you're moving forward, they would both have the same direction and you would be speeding up in that case. If they were opposite directions, let's say, for example, your velocity was positive, but you were slamming on the brakes, your acceleration would be negative, you would be slowing down. Hopefully, this helps you answer more effectively on the AP test the question about speed. We have a graphical method and we have a algebraic or sign-based method. Now let's consider two concepts that are constantly confused on the AP test. Average change in a function versus average value of a function. Average change in a function is simply found if this is the velocity function we have graphed. Average change is just the change in velocity over the change in time. That's found by just taking over the entire interval from 0 to pi over 2. That's found by just taking the velocity at the endpoints and calculating the slope between the endpoints. This is called the slope of the secant line. And this gives you average rate of change. So what we do for this is we just use the values. So you would find the velocity at pi over 2, subtract from the velocity at 0, and divide by the width of the interval, pi over 2 minus 0. This is the average acceleration. And it's also the average rate of change of velocity. So when we plug this into our original function, we put pi over 2 in, and we end up getting negative 4 for the velocity at pi over 2, minus the velocity at 0 is equal to 4, all over pi over 2. This ends up being negative 16 over pi. And since the units were meters per second, and the units on the x-axis were seconds, this would be meters per second squared, because we had in the top meters per second, and we had in the bottom time seconds. So the units don't cancel, they make meters per second squared, which is an acceleration unit. The next part is to be able to find the average value of a function. And the average value of a function is found by finding the whole area under the function and then dividing by the width of the interval. So you can see here, if we do the average value of the function, average value of a velocity function on the interval from 0 to pi over 2, you're going to get the area under that function from 0 to pi over 2 of 4 cosine of 2t dt from pi over 2 to 0, and you'll end up getting 0 because the area cancels out. But what if you want to find the average value in the interval from 0 to pi over 4? You'd figure that the average value would be somewhere around here, so that this area underneath that average line balances out with this area. So let's see what that's going to be. Same formulation. You're going to integrate it from 0 to pi over 4, but the width of the interval is only pi over 4 wide. So if we were to find this integral, we would just, the top part would be the antiderivative of 4 cosine of 2t. You would want to use substitution. Let u equal 2t. Let du equal 2 dt. dt will be replaced by du over 2. You would integrate, changing the limits of the integrals, because that's t equals 0, and that's t equals pi over 4. You would switch those limits, so then my lower limit would be 0 when I plug 0 into this. My upper limit would be pi over 2. My integral is changed to 4 cosine of u. The dt has switched to du over 2. And now I can integrate this function. I'm just going to do 4 divided by 2. I'm going to bring the 2 out in front. I've got the integral from 0 to pi over 2. And I'm integrating cosine of u du. This is a nice easy integral. This is going to be 2 sine of u negative, actually positive, because I'm checking this in my head. I'm saying the derivative of sine is cosine. So, and then I want to evaluate it from pi over 2 to 0. What does that equal? I've got 2 sine of pi over 2 minus 2 sine of 0. So now this is going to end up being the sine, this is going to equal 2. The sine of 0 is 0. So my area under the graph, if we go back to the original function, when I did the integral dt of, of what the function was when I integrated the velocity function from 0 to pi over 4, that was equal to 2 all over the width of the integral, which was pi over 4. So my average value of velocity on that interval is going to be 8 over pi. Now what's 8 over pi? Well, if you estimate pi to be 3, you have around 8/3, which is 2 2/3, which when we look at the graph, I'm just trying to make sense of this. 2/3, if this goes up to 4, 2 2/3 is about here. So that would mean that this area is counterbalanced by this area, and that looks like a pretty good average line for that function on that domain. Last question was to find the total displacement of the particle from 0 to pi over 4. Well, I've already done that because when I did the average value of the function from 0 to pi over 4 under the velocity curve dt and all the substitution I did, I ended up getting a value of 2 for that area. And if you want to go back and revisit how to actually find, to do that, you have to use a substitution method. Hopefully this video has helped you understand some of the different types of questions they can ask you if they give you a velocity function. And the most important point is this graph that I was using. Typically, they don't allow us to use a graphing calculator on the they don't allow us to use a graphing calculator on the non-calculator part, but this function is definitely something that you should be able to graph on that domain if you know your trig functions. Hopefully this helps, and I look forward to hearing your comments in the future. Have a good day.